Okay, hi everyone. We're Masters of Pi. We're not going to tread over the ground of the history of VR and stuff. The previous presentations were fantastic and kind of covering a lot of ground. So we're just going to go quite quickly through some of the projects that we've been creating in VR. All the demos that we're discussing here, we've actually got over on the table over there that you can try yourself and tell us what you think. And we basically, our kind of mantra for the company is technology made meaningful. So we get hold of the newest tech that we can get our hands on, and we just try to find meaningful ways of generating value out of this technology, whatever it may be. We produce games, we produce experiences, we're producing tools now. We kind of cover quite a lot of ground, but it's always the same reason for doing it. We try and always ask the question, what's the point? Why are we using this technology? And we try and find the experiences that are valuable within these technological platforms. And just out of interest, that's Hugo Gernsback with the TV glasses. That's 1963, which was a television strapped to your face, literally. So yes, we'll start with one of our first commercial projects, which basically was for Siemens, and it was an engineering project, and it's for a trade show. And what they were trying to do was communicate to their audience or their customers who had come to the trade show some very complex engineering principles, and a lot of it was invisible. It was electricity, it was energy flows, it was data flows. It was a lot of stuff that's very hard to visualize, and they're very interested in using VR as a way in a trade show environment to kind of communicate that in an interesting way and memorable way. So what we did before we even started building is we actually approached a Hollywood studio who build holographic UIs for film. So this way it's Guardians of the Galaxy, and they did Prometheus as well. So we kind of got them to, and we basically asked them the question is like, if you were to build an Iron Man style holographic interface in virtual reality, what would it look like? And if it's and it was using all the data from the engineering kind of sector, how would you make it look? Because we kind of think that a lot of although it's Hollywood and it's sci-fi and it's fictional, they are still trying to make it believable even on the big screen. So what they're still having to ask these questions of how would someone interact with it? What would the data look like if you could look in all 360 degrees? They were still having to kind of solve these questions even at a very kind of high level. So we took that as a guidepost kind of really to start. So this is one of their concepts that they did. And we were looking at exploring, so as a bit more detail, this is an engineering press, and these are giant presses which basically stamp metal and form it into car parts, car doors, things like this. And so the big challenges they have is these presses have to run very fast, they have to be very efficient, so a lot of the software that Siemens produces actually enhances this efficiency. So what we're trying to show is like a lot of levels of data that you can, the system is processing a lot of data that is invisible. You can't see it in the real world. So we tried to play with this idea of being transported into another world, which is the data world of Siemens. So you can switch from a real factory to the data version of that factory, and you can see data flowing and as you move around and interact. And so I think was there. Plug some sound in. But yeah, so basically we. There's got a video here, which just basically, which basically goes through, I think the show. Go on. So here's an example of an energy flow, which is electricity, electrical energy, which you can't really visualize very well in the real world. You can't visualize it at all. So it was a really useful way of communicating it to their clients. The clients got it immediately when they were showing it like this, in this context.
It's about seeing the invisible, really.
Yeah, seeing the invisible. Exactly that. So just a couple of, rewind a bit there. So just a couple of points, interesting things that we discovered was look at base triggers for things. So when you look at parts of the engine, at the top, the servo motors, they would pop up with the data that was spinning and changing to represent what was happening. We found, because a lot of the people using this were, it was from 30 up to, I think we had 80-year-olds actually tried as well. But it's definitely a casual audience. They didn't really know what 3D was. They probably never even tried VR. And we found look-based triggers was really useful for people to just be able, because it was contextual. It makes sense to look at something and then data peels off of it. It's a natural gesture. So we've kind of built this into a lot of the other demos and projects we do. Is if you don't want people to interact with a mouse or with razor hydras or whatever, you want them to just sit there. They can quite easily start to trigger things just by looking. It was just an interesting kind of mechanic that we pulled out. So
it also prevents kind of flooding them, because it's such a data-heavy project. If we'd have had all the data displayed even on a 360 environment, you've got quite a big canvas, but it's still a mass amount of data, and it kind of overwhelm you. So this is a filtering mechanism as well as a control mechanism. It just allows you to just relax a little bit instead of being bombarded with all of this kind of data. Contextual or not, it's still a lot of data. So it worked really well. Even things like the subtle fade and the speed of the rollouts were quite relevant. And we tested different speeds and different kind of fade points, and some were uncomfortable, some were comfortable. So even something as minute as that has a big effect in a virtual environment. So designing around virtual environments is quite different to traditional screens. Silly little tiny things like that you take for granted become a huge barrier for some people, and they end up throwing up.
It's basically spatial design. You have to think like an architect almost in terms of how the space works, because anyone can look in any direction. You've got to create cues to draw people's attention so they can look at stuff at the right time. And then contextual information comes off of where you're looking. I mean, it depends on what you're building, but essentially from the early stuff, these are these initial projects. Yeah, I'll talk about this in a sec. These initial projects, but that kind of stuff I think people should hopefully start to progress with that kind of interaction and see where we go, combining it with like gesture, like with the leap, or we got razor hydra demos, which we're talking about in a minute, for precision stuff. It hopefully will start. I mean, it's a new frontier. We've got a whole new interaction language that we need to actually come up with now, and it's very exciting. So this is the other VR experience. It looks better than this, but this is about dinosaurs. This is one of my drawings when I was 8 years old, and the reason I wanted to show you this was when my parents took me to the Natural History Museum, and I was obsessed with dinosaurs up from about 7 up to about 12. Proper obsessed with them, and I draw them. I love them. But when I went to the Natural History Museum, I saw Dippy, which is the Diplodocus, in the main hall, and I always remember I was just blown away. But I always imagined this dinosaur moving, coming to life. I kind of wanted to, and so what we wanted to do with this is we wanted to, as a kind of a demo, we wanted to see not only. Dinosaurs are cool in VR. I think that's just a given. But we were very interested in the museum context as well, because we've done a lot of trade show. We've done trade show stuff, and public experiences of VR works great, as you've seen with previous examples from the other presenters. Because you can also take the kit. You can get a PC in there with an Oculus Rift, and you can really crank up the resolution as well and the fidelity. But at the same time, in a public space, this is why we're interested in look-based triggers as well and things like this, because you don't need to then have mice and stuff around in a museum environment. So just putting a headset on and going from physical to digital, this is something that we wanted to explore with this as well. So you're in there, you see the giant skeleton, you put the headset on, and then you start to see other things happen. You get taken away from the museum, but you're taken on this journey and just given more information and added value to the actual experience of being there in a museum. And we think this is a really nice fit for VR, so we built a demo around it. And here's just a quick video of it.
What was the lightning ball? Was that a special power or something? You wrote lightning ball next to the dinosaur?
I don't know. This is how we imagine it could be in the actual place. And Dippy's being moved now, so we inadvertently have preserved Dippy in VR now. So Dippy being a Diplodocus. So we built the Natural History Museum and the Diplodocus as well. We're content creators and developers as well, so we build everything from scratch. So as an idea, if you do move exhibitions along, you can preserve them in VR within the environment, so you get digital preservation of physical elements of a museum, which could be another idea. And of course, you need T-Rexes, I think, in any dino demo. So I think I've cut it off here so it doesn't do any spoilers. We have this demo as well, so you can try this. So just let us know if you want to have a go.
Even on that point of inadvertently preserving that Dippy thing, is people are still doing that. You can, another use for the Oculus that maybe one for the future is people are going out and live scanning, as in laser scanning environments, and that applies to things that are to preserve historical sites as well. So Machu Picchu and all of these places that are precious to us, we can laser scan them and preserve them for posterity, and then view them, walk around them in our living room. So it sounded like a throwaway point then, but that's another avenue that's yet to be explored, and I think it'll be a vital one. Sorry.
Well, I'll pass over to Karl. This is Karl's bit.
Yeah. So as Matt said, we do client work, but we also make our own tools as well, and we're interested in kind of practical applications for VR as well as sales and commercial things. So we're both animators at heart. I did a character kind of animation back then. I pretended to be a character animation for many years. So I was always envious of people like Aardman or people who work in stop motion. They have zero UI to learn. They just, no eye is the best UI. So if they want to move an arm for a character, they grab the arm, they move it. And I have to read manuals, I have to learn user interfaces of 3D Max. It doesn't work, it crashes, it's a pain in the arse. So this frustration gave birth to this kind of concept. So we thought, how do we kind of translate that? Is the Oculus Rift going to allow me to do my job in a more efficient and even a more fun way? Because fun's still a relevant thing for the workplace. So here's a quick video. So we've been building this tool over the last 2 or 3 weeks, I think.